was every position down. There's some sort of every large company has their own AI. So I don't know what these Amazon might also have proprietary model.
All right, everybody. Welcome to the third meetup. Got Justin here. He's going to be doing his talk here on his Fuzz Fiction, and then that'll be about 45 minutes or so. And then we'll do our breakout tracks. So if you want to pitch something where you want to kind of do an async kind of offline project with people, or even a solo thing, now's your chance. That'll be your chance to kind of pitch what that is to everybody and let them know and see if you can get some interest in it. Myself, Nish, and Mike will give us, me and Mike will do an update, Nish is going to pitches, and then we'll do open forum and discuss anything. I've got a topic to bring up there, and got the JML how-to presentation to also kind of give a recap about that. And then we'll wrap up. Sound good?
Good.
All right, Justin. Get down chairs and grab some more. I can grab some more chairs.
This gets like
Do you have good in the chair or is that over? I can get
Well, we are a smallish group, so if you have questions, just interrupt me, and I will stop and answer whatever questions I have. So my name is Justin, and we're doing From Fuzz to Function, basically this idea of we have this abstract world of humans, and how do we turn that into something that's actually solid and concrete. I live here in town. I mainly have open source stuff, so there's a bunch of open source projects that I've created. Andrew is a partner in crime. We have an agency here in town called Ray. We do a lot of work with UVM and stuff like that. We're really like big in the Vue.js space, so we're sort of software engineers who write code and front ends and back ends and whatnot. But recently we've obviously gotten really into AI. And AI is interesting because we kind of have to face what the popular narrative is, which is that there's going to be global destruction. Although it's sort of hilarious because it alters between global destruction and it's something that's going to help me write my code. And that's basically like all we ever hear about it. Either Terminator's coming, or I can use Cursor to write my code slightly faster. And there's a surprisingly small amount of practitioners that are actually out there creating products and interesting things with it. We've definitely found that there's not even like very good best practices for how to actually use this to do something. So it's a lot of pie in the sky conceptual stuff right now. So before I move on, let's just talk about those uncomfortable questions. Will AI replace your job? If you're a developer, this is according to 2024 Stack Overflow, most developers think that it will not replace your job. And a few of them think maybe, but yeah, for the most part, no, it's not. They'd say it's not going to replace your job. So should you use AI to write your code? How many of you are developers? Any of you software engineers? Okay, so a good mix, a little over half. Yes, you should definitely use it to write your code. If you're not already using it, I would definitely get on board as soon as possible. Will it replace you? Yes, it'll definitely replace you. Will it destroy the world? No. Maybe. Yeah, it's going to destroy the world. But do humans have value? We still have value. All right, so there's a little comfort, a little warmth in our heart. As the world is melting away, at least you'll know that you matter. But we're not going to talk about any of this. I'm only putting this here as a precursor because you have to do this in every AI talk. This is what I'm really going to talk about. How do we create AI first apps? So you might be familiar now with the magic wand that is popping up on all these different like SaaS products and apps and everything like that. Everybody wants to put some AI into their pre-existing product. And most of the time it's garbage, and I don't really recommend this. If you guys have a product or you work for a product company and they're like, your boss is like, hey, how do we get some AI in sit down and rethink the whole thing. Like, how if AI worked, because it will work eventually, maybe not in this exact moment, it will work, what would that actually look like? So, what do I mean by AI first? This is my definition. My definition is an app where the primary input mechanism is non-deterministic. In other words, you're not just pushing buttons, you're taking in fuzzy input from the outside, and that fuzzy could be a photo, it could be text, it could be a book, it could be the way somebody smiles, whatever that fuzzy input is as the primary input mechanism. Doesn't mean you don't have buttons and other things like that, but that's the primary way that you use the app, which is obviously in contrast to, let's say, Figma or one of these other apps where they're adding in some AI features here and there. The primary way to use it is still by dragging boxes on the screen, but you have some ability to do some neat things. What would it look like if you booted up Figma to do your design and it had none of that? It was like, why don't you draw a napkin sketch first, or something like that. We're actually used to this because, man, it's been ages since Siri came out. I want to say, actually, I don't know, 2008, maybe? 2009, 2010? I don't know, somewhere around. It's a long time ago. 2010? Okay. It's been over 10 years since this came out, and its primary input mechanism was spoken word. Now, it was garbage, and it still is garbage, ironically, but you're kind of already used to this idea of something being AI first. So let's dream a little bit, whole new world, and what I want to kind of encourage everybody to think is you could actually start building this stuff today. Like you could go and build a product that's AI first today with the level of quality that exists. You don't have to wait for the singularity or some AI revolution or anything like that. There's enough intelligence in these things, easily enough intelligence to create some real product value out there. In fact, I would say if AI stopped advancing today, there's at least $10 trillion worth of new products that are going to be built on the back of the existing technology. There is a lot here. So, just some harebrained ideas. What about an off-hour triage for medical offices? Like, I have kids, we call them all the time, we're like, hey, my kid is sick in the middle of the night, what do? They say, I don't know, I'll call you back. Maybe, if the doctor wants to, right? How about something like a personal stylist? You wake up every morning, you take a picture of yourself, and you've got your buddy who's like, that green's not doing it for you, right? Something like that. How about a curriculum, maybe like a homeschool curriculum or something like that includes the teacher. So it actually is, it's books and things like that with somebody who will walk you through it and help you learn. You could actually build that. Contract analysis. So many contracts out there, nobody ever reads them. You just give it to it and say, like, is this good? How am I going to get screwed in this contract? You could finely tune an LLM to be incredibly good at that. A third-party insurance advisor, right? Like you could build an insurance advisor that is not tied to any insurance company, that can shop the market, one of the world's most boring things. But the reason it would be really great for AI is you could have a conversation with it, right? It could talk to you and be like, what are the things that matter to you? Oh, you've got kids. Oh, you've got, like a brand new car that matters or whatever, right? It's personalized in a way that we really haven't had in the past. The problem is, we haven't seen any of this. I mean, very little. There's a lot of hubbub in the AI space, like around maybe images or videos. There's a little bit of chatbot kind of stuff out there, but really we haven't seen that much. And the reality is that AI just isn't very easy to work with. It's like surprisingly hard actually to work with it. And that is surprising when we come from someplace like ChatGPT. So why is that? Well, I've got some of the reasons that, and this is where I go into sort of war stories now, working with this. Some of the reasons that I have found this is hard to work with. There is absolutely no standard approach for how to build an app with AI. This does not exist yet, right? If you're going to build some sort of like a website or something like that, there's half a dozen tools out there. No, there's way more than that. There's dozens and dozens of tools out there that you can use to create an app tomorrow. This is really profound, but there is a complete lack of intuition. We all have a sense of built-up intuition about the way the world works. And AI, I would say, it's like a little bit like quantum physics or something. It defies our preconceived understanding of how things are just going to work. They don't just work that way. There is very little tooling that exists. There's tools coming out all the time, but like they die within a month. So the standards are sort of eroding and shifting constantly. And the models are stupid or stupid expensive. Like those are the only two options at this exact moment. So, no standard approach. What do I mean by that? Well, we haven't even solidified like what a UI would look like when you're dealing with an app that's AI first. The closest thing we have at this point is something like ChatGPT, where you input some text. But it's unclear whether that's going to be the future or not. We don't know. Like maybe the voice modality really takes off. Maybe it's all vision-based, or maybe it's some amalgamation of all of those kind of things. We don't really know yet. Things like, can you rely on getting a one-shot response back, right? If you send it an LLM or even a vision model, a query, and it comes back with an answer, can you rely on that actually being true? You have to determine that for yourself and for your own application because it's unclear at this point. Do you actually need to build an agent? What is an agent? Do we even know? How about like getting structured data out? It's pretty useless to just get text output, which is what ChatGPT gives you. There's a little lie inside of these things, which I will hopefully uncover a little bit of. But getting structured data out is surprisingly hard. How about a lack of personal intuition? So if you're a coder, you're familiar with the Fibonacci sequence. This is a function which produces the Fibonacci sequence. And this is the function that produces the Fibonacci sequence. And this is also one. Okay? They all do exactly the same thing. They're just written in different ways. And if you write any code, and even if you don't, you might have some personal intuition about which of these is better. Who thinks this is the best? How about this one? Second, we got one vote, 2 votes. Third, some hands. It's a little bit of a personal thing. I kind of like this middle one because I can read it really easily. This one uses some fancy pants stuff, even though it's nice and concise. Whatever, we have a personal intuition that we build up over time if you're a software engineer. But how about something like this? Here is a cookie dough recipe creator for an LLM. These are the instructions that you're going to send the LLM, written in plain English. Okay, so that's one. It's written sort of here in a markdown format. Here's another in sort of an XML-like format. Here's one that's pure text. What does your intuition tell you is the best one?
Probably the same.
It changed. For me, markdown used to work better than XML work. Depending on the context, there's no clear...
That's exactly right. It completely depends on the model. Depending on which model you use, one of these is better than the other. It's crazy. And we don't have any intuition built up for which one of these is actually going to be better to work with. And you eventually build it up through scar tissue, I think. But
So do you really, so it sounds like you're moving towards the idea that structure is everything when you work with AI, but the idea behind AI is to not be structured. That's the idea, right?
so that's the idea would be that
So
the
what,
input is
my
not
question
structured.
is, why does it matter? If one is XML and one is...
Oh, that's a great question. It matters a lot. It matters a lot. I can get into that a little bit, but fundamentally, the outputs that we get from AI right now are fuzzy by nature. So it's fuzzy in and fuzzy out, which means that the utility that it provides for you is actually very low, because it takes another fuzzy reader to understand what that output is. So ChatGPT gives these miraculous answers to you, but the output of ChatGPT is purely linguistic form. It has no real understanding of what it's saying. So, like an easy example is if you ask ChatGPT to give you like a cookie dough recipe, and you ask for it in a paragraph form, it'll write a great one for you. If you ask for it in a JSON document, it will give you a bad one. It's the same thing. Why does it matter? Well, it matters because it's modeling the linguistic form of the language. And linguistics are even deeper than English or French or German They have patterns and ideas and reasoning behind them that are very deep and complicated, and frankly, humans don't understand them very well, which is why there's a debate about whether or not LLMs are the right solution. And everybody was surprised that so much intelligence came out of LLMs because we didn't think that language had that much baked into it. Turns out that it did. But you can't build almost anything with that fuzzy output. You can only take fuzzy input, fuzzy output, which is why chatbots are sort of the only thing we've really seen. So we want to get more structured output out of these things on the backside. It's the same reason that like stable diffusion is not necessarily a great thing for photo editing, right? It's because you say, okay, I want some guy lifting weights, and it'll make a photo for you. You say, I want the barbells to be red. You get a whole new image every single time because there's no structure behind it. Does that sort of answer? At least that's my opinion on this. Tools. There's very few tools out there. You want things like stream parsers. You need to do. There's no great testing tools. There are testing tools, but there's not a lot of good ones yet. LLM chaining. There's a bunch of tools that are starting to pop up now for chaining LLMs together, but there's not actually that many that are available. Isolating your state is incredibly important. So if I'm going to chain two LLMs together, the second one that I chain, I might want to give it no context or some context or pieces of context. There's not a lot of good tools for that. Routing between models. So if I need something to use Gemini and then GPT 4.1 or something like that, getting those routings to work well. Multiplexing streams. So streaming is really important, where you're getting the information back from the LLM as it's being produced, so you don't sit there and wait for it in completion. And if you do it in multiple streams at the same time, you have to figure out a way to get all of that back to the user in some particular way. And there's not a lot of great options out there for this. Context injection. There's now, people are starting to develop some tools for context injection, but it's still very primitive. And validators, structured validators. So if I need some structured content back, make sure that the structure comes back the right way. These are all tools that are in their infancy. They are not well established. None of them really own any part of the market. I would guess that most of them will be gone in 2 years. Models are stupid expensive. This is crazy. These are both from OpenAI. Exact same prompts, sort by the biggest. And we get a completely inaccurate answer over here and the correct answer over here. Well, what's the difference? It's only 16 times the price. It's the actual price difference between getting the right answer and the wrong answer. And this looks great. It matched the linguistic form of what I needed. It just was wrong.
Which models did you use? I'm just curious.
This is 4.0 mini, and that is 4.0.
Yeah.
When you say they're stupid, expensive, stupid expensive.
Yes.
What do you mean? How do you mean stupid expensive? In comparison to hiring a developer, if I wanted to build a website, it's very cheap.
And that, it depends on your application. It could be that that's cheap for you, but let's say Cursor. Cursor is losing money. They could not possibly lose money faster than they are losing money. If they are losing money very fast because the actual cost of those LLM requests are high. Which they'll fix this, right? They'll start to add in. They're already doing a lot of context switching, and they're starting to have you pay for the higher end models and things like that. You can easily. I have friends who do exactly what you're saying, which is they pay a developer. They stop paying developers, and now they use exclusively AI models. And their bills are $10,000, $20,000 a month for using these models. Because if you want to use ones that get the answer correct, it's very expensive. So
that's a market maturity issue too. I mean, AWS was
100%.
stupid expensive, when it started.
Absolutely.
So the competition came in and things scaled, et cetera, and suddenly it became a horrible financial option.
yes.
Right? Companies said, okay, I'm going to grow on AWS with one rate review, not just because it's cheap, but because it's better.
Right.
This way, we're willing to pay that, but we've got the budget. We've got to account for that in our OpEx model, our product cost model, make sure, all that good stuff. So I mean, that's a time and market, kind of market.
It is, and what you're identifying there's a gap in the market right now. But one gap in the market right now is
Are we still over the castle? Would you say? I think we're probably still over the castle.
yeah, probably.
Yeah.
There's also like very little in between these points. There's not very many models that fall in between the low end and the high end. I'm sure they will get developed over time, and I'm sure what we think of as a good model now eventually will be trash and cheap. So this will all change with time. But yeah, if you
I'm sorry,
want,
I have one more question.
Yeah.
You're doing a lot of that stuff. Is there a place that you go that is tracking the relative accuracy of these models that any of us can go to and say, this is the crossover error rate of this model versus this model versus this model?
I mean, same place other people go. I like Chatbot Arena a lot.
Say it again.
Chatbot Arena.
Check
They have basically like a chess elo score. And of course these models like now are sort of trying to game it, you know, so like Model 4 got amazing scores, even though in practicality maybe doesn't do as well. But the thing I really like about it is they have I'll pull it up here real quick. Oh no, how about that?
The internet's all wet.
That's fine. So they have a leaderboard here with a price analysis, which is one of my favorite things to take a look at. And so here you can see on the x-axis you have the cost per token, and on the y-axis you have the ELO score. So in a perfect world, you want to be up here, cheap and good. Gemini 2 Flash scores well on these in general. But like, you know, here's Gemma 27B, and it's not actually this good. So you have to take these things with a bit of grain of salt. But directionally, it's right? Like 03 is up in that top right corner. It is exceptionally smart and exceptionally expensive. So you do get some good information out of this. But again, it's like it depends on your application, right? What I'm most interested in is trying to be a practitioner that takes what's available on the market right now and tries to build something compelling out of it. And that's where I think things are pretty stupid expensive. It's hard to justify the cost to a consumer. Maybe B2B would be a little easier, but to a consumer it can often be hard to justify the cost and be profitable at the same time. All right, some solutions. So patterns are emerging. These are some things that we've done, building a tool I'll show you here in a minute, and some things we found. You probably want to use a router. What do I mean by that? Well, your user gives you a query. This is LLM land. It goes into your first prompt, where you basically have layered on system prompts and things like that, and this router is trying to determine effectively how hard is the thing that they're asking you to do. How much intelligence does it require? And then it produces some kind of breakdown coming out of that. So, okay, I'm going to go to the simple model, I'm going to go to the medium, or I'm going to go to the expensive. Coming out of that, it's going to select a function. These functions are commensurate with their difficulty, right? Or a tool, right? A function call or a tool call. And it will select one of these tool calls. It will then actually do something deterministic. Maybe it saves, that function is then capable of saving something to a database, creating a CSV, doing something that you actually have structure behind. And then finally, at the end of it, you sandwich it with an LLM reply. So this would work really well in like a chatbot kind of context or some sort of feedback loop. If you want to make it agentic, which is the hot topic this year, you basically give that reply back to the router again, and you run the system over again. And that's about it. This little feedback loop is effectively, I mean, obviously it's always more complicated than that. That is effectively just what an agent is. You take the output, it becomes the input. You take the output, it becomes the input. And then the hardest part of an agent is getting it to stop. And that's also the risky part, because it could cost you everything. So you definitely want to use tools. That last one just showed tools. And here's how I describe tools to people who aren't developers and people who are developers that haven't worked with them. Has anybody ever run this command Emacs, done it?
I'm not wading into this.
So this is a game that ships inside of Emacs. It's pretty crazy. It's a text game. It's been there since like 72 or something. And it starts and it's like, you are in a forest and there's a road going off in the distance and laying on the ground is a hammer and over here is a cup of water. What do you want to do? That's what tools are. They're just textual descriptions to the LLM. You literally just make it up. It doesn't mean there's any function or actual tool there. You just make up a tool. You say, there's a cup of wine. How much do you want to pour into it? And then the LLM responds. That's all a tool is. It's nothing magical. Now this is the actual, there is a shovel there. There's your tool, okay? So here's an example. I've got pour beer, pour wine. These are two different tools. And this is actually like what you would send to OpenAI if you're unfamiliar with it. You would say, what's the name of my function? Pour beer. Why would I do this? Oh, this pours a specified amount of beer, so on and so forth. And then the result would be something like this. It gives you a value back. This is how you need to. This is like how you need to interact with AI models, LLMs specifically, if you want to be able to get deterministic-like results back out of them. The problem is that you will quickly take this too far. And this is where sort of the intelligence level of these models begins to really show. They are quite bad at this. They are really quite bad at it. They will use the wrong tools all the time. They will be overeager to use the tools without enough information, or they'll be overeager to use the tool, or undereager to use the tools, and they just like won't pour the damn line. Whatever your problems are, they will come up and very quickly show you new ones. So those are tools. You probably want to use them. You also probably want to use streaming, and one of the reasons is the actual experience of using these tools is pretty bad if you wait for the complete response. Like even ChatGPT, if you were to take ChatGPT and remove the streaming capability and wait for the entire thing, and it just popped on there at once, it's a bad experience. It's actually a really bad experience. So you really want to be getting these tokens as they're coming. Even if what you're producing at the end of the day is something like an artifact, like let's say a photo or a CSV file or something like that, you at least want to know that the tool calls are happening as they're happening and firing them as fast as possible. So streaming is the only real way to do that. It's interesting because the web is really underdeveloped on this. There's like not that much textual streaming tooling out there right now. So I'm imagining in the next year or two, this will really start to explode. So change requests, this is a great example of like why you would want to use tools, why you would want to use streaming with tools. As the tools are coming in, let's say it's pour wine, you want to be able to say to the person, oh, the wine is being poured before you even know how much, right? So you can dispatch those faster. You can update the UI in real time, of course, and it also allows you to do really neat things with introspection on the information that's coming back. So one neat feature of tools is you can automatically, flashlight. One of the neat things about readable streams is you can just call T on it at any time, and it'll take that one stream of bytes and break it into two streams. So I do this in our software all the time, where we have a stream of information coming back, maybe it's tool calls or something like that. I tee it off. One of them can go to a logger for us to introspect. The other one goes off to the user. I wrote an open source library, it's sort of open source, recently, like not too long ago, that basically lets you take these streams as they're coming in and interpret them before they're complete. So most of these tools return JSON, and you can stream the JSON back. The problem with JSON is you need the entire string to be able to use it. So this tracks how many bytes in we are, how many quotations we are, and it knows how to close that so you can get streaming JSON as it's being generated. You might want to use multiplexing. Multiplexing, is anybody familiar with that term? electrical engineering and whatnot use this term quite a bit. It's a simple concept. In AI terms, I'll describe it like this. You have a server, maybe you've made 3 LLM requests on the server that are parallel. Not serial, they're all parallel, they're happening at the same time. And we want to stream that back to the user as fast as possible. So you basically have one HTTP stream that's open to them, and you take all of the data from your LLMs, you throw them into that with some sort of byte marker delineation for which ones belong to which channel, and then they pop back out on the other side, and now you can pass them around to your clients. I'll give you a quick example of how we did this once. So this is a tool that we wrote. We have a product called FormKit, which does form-related stuff. And I'll just pick one of these. So here we go. Here's a database table. And it's going to send the SQL for, you guys can't see any of this, can you? All right. It'll send the SQL along to an LLM in this attachment. And you can see what's happening here is it's generating a form, and it's generating multiple inputs in parallel. And by doing that, and we can stream those directly to the user instantly through a single stream instead of having to wait for one by one to serially get created. So that's what multiplexing can do for you. All right, here's a pattern that I've started to adopt. It's start with a stupid model. If you have this binary classification between a smart and a stupid model. Start with the stupid ones. So I would recommend 4.1 Mini or Flash 2.0 if you're going to build something with an LLM. And the reason is, it's sort of like using an old browser when you're building a website or an old device when you're building an app. You kind of want to start with the lowest level of intelligence and see if you can get your structure to work well there. Can I architect this thing to work with something that's not that intelligent? Because then when I add intelligence, at least in my experience, 100% of the time, it improves the product. Okay, so you want to get it as close to usable with this first, and then only add the cost where you need the cost. Gemini 2 Flash is actually incredible and incredibly bad. It's so good and so bad. It will reply, it will do incredible replies and do incredible things, and then just completely screw up. 4.1 is much more reliable and just on average a little bit dumber. So you need to build up your intuition for prompts. So first thing that was really hard for me to understand 2 years ago when I started working on this was that LLMs are stateless. They didn't seem stateless because ChatGPT knew what I said between message 1 and message 2. If you are unfamiliar with this, it's sort of, it's the table stakes for working with these things. You have to send the entire conversation to the LLM every single time. So in ChatGPT, when you say, hi, how are you doing? And then it says, great, how are you? What can I do for you today? And you say, I'd like you to make a cookie dough recipe. It sends the entire conversation back to the LLM every single time. The hi, how are you? All the replies, everything goes back every single time. They are completely stateless. And so you are recreating the state every single time. You generally want to constrain your LLM to a small number of decisions and then give it as little guidance as possible. I've fallen into this trap so many times where basically I am using an LLM to do something, it does something I'm not expecting, I don't like it, I go in, I throw a little prompt in there, it's like, hey, don't do that. Okay, now my prompts start growing and growing and growing and growing and growing, and pretty soon you have conflicting prompts and all other kinds of problems. Instead, what you want to do is try to restrict the number of decisions to be as small as possible, and then if you need to add more decisions, have a decision tree, almost like a phone tree. This guy made a high-level decision, which went down into a lower-level decision, which went down into a lower-level decision. This is very practical, but you need to describe the tools in the system prompt and the tool descriptions. So if you saw back before where we had that JSON block for describing what a tool is, it has a description in the tool that says, hey, this is when you would want to use me. You also need to tell it how to use it in the description. I don't know why, This is just the intuition that I had built up now. Also, you always want to put all of the dynamic data at the end. If you were to look at the system prompt as the top thing that gets sent to the LLM, and then the conversation, and then somewhere down here is the user, all of this should be static. Static, 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 until the very bottom. And the reason is that most of the providers, with Google being the exception, they allow you to cache all of that. In fact, they do it for you automatically. And you pay half the cost. So if your system prompt has dynamic data in it, you cache and validate immediately. It's based on chunks of 124 bytes. So you don't ever want to put anything dynamic in your system prompt or anything like that. You want to put it at the very end. Also, you don't want to inject any context in the user prompt. This was a big mistake that I made as well. Built multiple apps doing this thing wrong. Don't use the user prompt to tell the LLM what to do. It will get confused almost every single time, and it will start talking back to you at some point. Maybe this is like a month after you've launched your product. It'll just start talking to you as if, or talking to your user as if it was the user, or you were the user, or the system is the user. It gets very confused. So what we do now is we artificially inject a tool call, because the chat history can also include tool calls. So we artificially inject a tool call at the very end that's like load context, and that's how we get our context in there. This is a really key point, and it's really key because it defies our initial intuition that the chat has to be what the chat looks like to the user. It does not. You can lie, cheat, and steal to these LLMs all day long, and in fact, you probably should. So let's say that you have, like Gemini, for example. We found that Gemini gets over-reinforced on the chat context. So if the Gemini assistant replies with an emoji and it's like thumbs up, then the next time that you're having the conversation, it sees that emoji that it replied with last time, it's like, oh, maybe I should use one of those again. And then the next time, again. And pretty soon you'll find these like almost harmonic resonances starting to build up inside of the AI. You can get around this by artificially injecting a message from the user that says, hey, can you stop sending emojis? And then artificially inject a response from the assistant that's like, oh my gosh, I'm so sorry, I'll never do that again. That part of the conversation never happened, but it's incredibly effective at redirecting the LLMs. So you need to learn to lie to the LLM in a lot of different ways to get it to sort of do what you need it to do. All right, so here's the thing that we're building right now, and I'll show it to you just as a way of kind of getting you guys thinking about how to use these LLMs. This is a personal fitness coach. It is not public yet or anything. We're basically, I don't know, in like friends and family mode right now, so like a few people are using it, but not very many. And it essentially allows anybody to get like a contact card from a trainer, just like you would from a person. It has a photo, it has a phone number and everything, and it's your personal trainer. You text it information about yourself just using the Messages app. It texts you back. It creates workouts for you. It sets them up. You get to see them. It tracks them in the gym. It'll schedule them on the calendar. It'll give you an iCal link that you can use to go like track it. It'll send you a reminder the night before, be like, hey, you ready for your workout? It's tomorrow morning at 8 a.m. Hey, 30 minutes to your workout. You're gonna be there? Come on, don't screw up. You show up, gives you a link to a web app where you actually get to track it, and it's all powered by AI, and it's AI first. So I am going to pull up a local version of this.
Now that's a little different than what you were talking about with the streaming though, right? Because your SMS and or RCS, whatever it is.
That's true. That is fully turn-based. You don't need streaming for that at all.
So are you finding that the experiences are?
No, we have to do some cheats in there. So if part of that routing process also can tell us like, hey, if we're going to modify an exercise, we know that that's actually pretty expensive because it takes a high level of intelligence, and we're going to use a thinking model. Thinking models are slow. So when the router has routed it in that direction, we will actually send them a reply and be like, yeah, I'll do that for you. Give me 1 second. and that's our solution. But interestingly, we are still using streaming. We use it internally, even though we're not showing any streaming replies to the user. At least in the text, in the app part, you actually do get some of that. But in the text part, the SMS part, you don't. But we use it to make sort of optimistic tool calls even before the streaming is complete. So if you say, hey, I want to schedule something for tomorrow and do this other thing, as it streams in and it's like, okay, I have the first thing to do, let me dispatch that. Oh, I've got the second thing to do, dispatch that. And by doing that, we're able to speed up what we're doing.
And you found that you're able to see model side faults or performance segregations, things like that in the multiplex stream? Were you able to detect those?
That's a great question. No,
Not yet.
not yet.
But you're working on it.
No, we're not going to work on it. We're not going to work on it. We do, we put some error correction there to try to assist with things. But we only direct stream like that when we are really, really confident about the reliability of that model.
I see.
So OpenAI in particular will guarantee you compliant JSON. They make a 100% guarantee on it as long as you flip some switches. And there's some downsides to doing it, like you can't do parallel tool calls when you do that. But if you do it, they will do the validation on their end as it's streaming out. I don't know how they do like this, like the back propagation to get that to work, but it's very cool and it works. Okay, I'll just show you this onboarding flow here. So I go sign up. I get to pick my trainer. Let's see, I'll do Marcus. So here's where I would download my contact card. I'd add it to my phone. I'm not going to do that. Here is onboarding. It's all pre-filled for me because I've done this 1,000 times. Let's actually get text with it. 6, 6. All right. Bear with me. It's my coworker Lon, so he won't mind if I buy this. That's strike test mode.
And
Woo!
Is it AI generated code?
It's
Good looking for that.
somewhere here? No, it's not even in here. All right. I don't see one. Okay. Well, he's not in here. I'll start with one of these other threads. All right, here you can see, this is a result of an eval. Here you can see how it worked. This is basically man, you guys really can't see this very well, can you? This is the admin tool that we use internally here to produce this. So these are the conversations that are going back and forth. And then we built up our own tooling around this. So like I can click on this message and I can see, if I make this really big, I can see the actual LLM request that was made. Down here, I can see the actual prompt, the context, the system message that was sent, the history state that was actually sent along to the user or to the LLM, and then the reply. So in this case, it came in here into the onboarding router. It performed an action called set remaining questions. This is a trick that we have for having a continued conversation, because if you don't do this, it will preemptively call your tools for you. Without saying, hey, you've got 5 questions left to ask or something like that. Then what it would do is say, hey, how much do you weigh? 180 pounds? Great, here's your workout. We don't want it to do that. We wanted to actually have a conversation. So this is an interesting hack where we use an expensive model with low context to tell a cheap model how much room, how much latitude it has to continue to reply. So I can come down here, here's my, okay, got it, that's my workout. Okay, awesome. When do I get started? And when I send that, here you can see these things firing off. schedule workout router, so that's the router that decides what does it need to do. It decided it needed to clarify information before it moved on. So then it went to the responder. So if you remember that diagram I had where we had an entry point and then a responder at the very end, that's what's happening. It does a bunch of decision making in the middle, and then at the very end, it is able to look back on that. And this is actually great because it also can detect errors through the process. So if an error had happened at one of these other points, then my responder is given, in this case it's going to Gemini. Oh. Remember, stateless, so we have to recreate state. At the end here, you can see these function calls and things like this that are injected in here. These are not actual functions that were run. These are fake. The LLM has no idea what time it is. So one way you can solve that is by putting it in the system prompt or something like that. Well, now you're going to validate your cache. And it also doesn't know when you have a long-running conversation. If I say, if the LLM says, hey, are you ready for your workout tomorrow? And then tomorrow comes, and it's going to send me another reminder. The reminder will probably be like, are you still ready for your workout tomorrow? Even if we've told it what today is, because the conversation doesn't ever say that time passed, it doesn't really know it, even if it's in the prompting. So what we do is we inject these artificial times in there that we say, hey, load current time. Or if there's a big pause in the conversation, we'll inject one that says, conversation pause detected, right? And these are sort of the lies that we tell it. Up here you can see this was the tool call performed right here where it asked it to clarify. It said, to get you started, I need to schedule your workouts. What days and times work best for your first workout, core and stability. Okay, so that's not actually what we sent to the user. That just got passed on to the responder through the conversation history. The conversation history now includes this, and so when the LLM now needs to send another response, it has something to go look at. If one of these things had failed in there, then we can say that the function response was some form of error. And then the responder that comes at the end is able to say, hey, for some reason I wasn't able to do that. Can you ask me again? Maybe a different way? And it's able to give these really nice fallbacks when you hit errors that sound extremely human-like. It's really wonderful. Let's see, schedule workout of daytimes. Let's see.
Is the responder non-deterministic, or is it also using an LLM?
LLM. Yeah. So every morning at 6 a.m. Let's see what it does here. Okay, so here's another thing. You see here we had 2 LLMs fail in a row. This happens all the time, especially with Gemini. Gemini replied with text that was in a code format. This is infuriating. I have long conversations with Google engineers about this. They don't understand what's going on either. Here it tried to call a tool in the text reply called schedule workout. That does not exist. There is no such tool. It was not given such a tool. It just decided to hallucinate it. We catch that. We fail it. Then we retry. Here, we know we're retrying. We say, hey, you previously failed. You failed to reply with a valid text reply to the user. And then we explain like what it did wrong, and then we rerun the LLM again. In this case, it failed again for the second time. So at this point, we are done with Gemini 2.0 Flash. You failed me. And we're going to revert to 4.0 Mini. So we have big trees in the code base of when this LLM fails, this is a good substitute. If that fails, we might need to increase the model intensity, and we'll actually go to a more expensive model. And we have those things kind of mapped out so they know how to move between them all.
Architecturally, how did you figure out that it was a fail? There's an evaluator for each response somehow?
That's a great question. It depends. Sometimes it's just deterministic. We get a 429, we get something like that, and we can just know that it failed. With Gemini, this is such a reliable problem that we're actually able to just detect that explicitly in the code. But we have a bunch of deterministic only evals in there that are able to look at replies. We don't use any, we use evals like LLM-based evals, but we only use them in post-processing because we need to reply to the user too fast. Also, an interesting note about this, we recently ran a lot of testing on evals, and we found that cheap models are unable, like literally, it's a Rorschach test, they are unable to make a determination about the quality of a response. The only models that are able to do that effectively are the expensive ones. And I have picked my brain to death about this. I think it has to do with the fact that the linguistic form that an LLM produces is naturally its own linguistic form. And so even if it's bad, it thinks it's good.
We ran into that other problem. We got access to, I think it was ChatGPT's reasoning model about a month ago. And we started running those through the reasoning. The reasoning model seems to be better.
Yeah.
I think the language model, I think if the language, so like the morphology, I don't know if this is just in my head kind of thing, if the morphology is right, it's right. I can't find anything wrong with it, so I can't say there's
Feels
anything
good.
wrong with it.
Looks like
But the reason, yeah, it's an element, right? But the reasoning models seem to be pretty good at that.
They are. They're much, much, much
They're
better.
really expensive.
They are really expensive. Yeah, we ran tests on literally almost every model that is in existence. They all either, it was like a pass-fail, like a complete pass-fail, where we would give it the same exact scenario where there was like an obviously horrifically bad reply, and every single cheat model said it was a perfect reply. This is a 9 out of 10, this is very good. And then right when you cross a threshold, which in our case was actually, we could do it with the latest versions of 4.0, kind of crossed this threshold, and they were able to start making good evals on it. And then the reasoning models were the best, like 03 was excellent, very excellent. So that is an interesting little warning sign that we found. Okay, hold on, I want to get this thing to actually produce some markup.
Have you tried replicating the reasoning process manually? Because reasoning
Yes.
models is just chain of thought.
They are just chain of thought. We do that actually, yes. We do that on some complicated things, like when you're going to plan a brand new workout in our case. A brand new workout we found is too hard for it to one-shot. So we first pass it to a model to use linguistic form, right? Just what it is best at, to write out a paragraph-long description, and we take that and we pass it to another one that tries to structure it, and then we take that and pass it to another one to try to match it to our predefined data.
It seems like the prompt chain,
Yeah.
which you build using this solves 99% of problems, at least for me. Like if I have an issue, first pass, 80% success. If I use another model to look at the first result and initial prompt, and then see and produce an improved version, my accuracy goes like 98%. It's such a big jump with just second step.
With just two?
Yeah.
Okay, that's interesting.
Well, it depends on the use case. I have, for example, an app that does ancient Greek. That takes 4 steps to produce the proper final form. So it does a conversion, linguistic conversion.
Is the length of that variable, like if it passes a good eval at one time, will it say, okay, 2's enough now, or?
I just found out the minimum, again, the minimum 100% pass task. So the task turned out to be 4 steps.
Okay.
For 4 API calls.
Yeah.
And the
Four
task
different models.
No, for all 4 calls.
One thing that is available over here, you can see the actual cost of these things coming through. So like that message and reply was a total of a tenth of a penny.
So you had to build this tool?
Yeah.
Have you considered you might make more money selling the tool than selling it?
We have experience selling to developers, and I decided it's a bad idea.
There were 2 guys that did that a long time ago, named them Drayson and Hurwitz.
Okay, so let's say, I don't know. You got me. Wednesday? Thursday. The fact that you can have spelling mistakes is amazing. All right, so here you can see we got past the onboarding. It actually did work. And in this case, so here it decided it was going to schedule multiple workouts. And this actually produced all of these different function calls. And with exact, the target time, the exact time it was going to be scheduled for in their local time, so on and so forth. Then we can take that result and we can actually do something with it. We can put it in a database, we can actually create deterministic results for them. The fact that those happen then starts dispatching things like the exercises to actually get created. This is where we use a couple of simple chains. So the result of this exercise router is actual textual content that describes what's the right answer here, what's going to happen. It takes those and then creates actual structured workouts from it, and then it takes those and passes them to another function. You get this sort of LLM chain, and at the end you're able to actually go in and let's see. Here I can see my 4 workouts that are on the calendar. I can go into the one that's coming up here. Come on, baby.
You write a book club app to make sure we're all reading the chapters. It's not a project like.
Does your user not have a defined gender? That's it.
I don't know. Is that even possible? I don't even think gender is a field we store. We just store sex, right? Whatever.
So, I mean, I kind of get the idea what sort of an app this is. What sort of a ratio are you finding that you're having to use between the cheap model and the more expensive model? Is it like 50/50? Do you end up, only barely using the cheap and having the...
We only barely use the expensive.
Okay.
Yeah. Yeah. The actual, if I pull this back up here and we go look here. Here you can see these were expensive, right?
Yeah.
Creating those exercises was all a penny. But if you look up in the rest of this chat here, you can see that they're all just fractions. These scheduling stuff is expensive. So when you move things around on the calendar, that takes a little bit more intelligence, but this entire onboarding process is relatively cheap. Actually, the largest cost for this is by far the SMS cost.
Sure.
Yeah, by far.
Twilio?
Twilio, yeah. And we are thinking about trying to use more intelligent models in a couple of different places, which will increase the LLM cost. But yeah, but in general, that's it. Yeah.
So, I've used this, and it's very just
Oh, cool.
very surface level. I completed one workout and had some stuff on the calendar. I was impressed that it asked me what questions you have at home and was able to customize exercises that took advantage of this.
Yeah.
My question is, but in the future, if I say, make the workout longer, okay, is it going to remember that answer? Where is that stored? And is there sort of a RAG element? Can you talk about that a little
Yes.
bit? About what kind of persistent state, how you handle persistent state?
Absolutely. Yes, so there is a lot of context about the user available to it, including previous workouts. The most important part is you have this, it's so hard to show on this incredibly tiny screen. You have this workout rotation here, which is like your days. You never actually see this as a user, but behind the scenes, it knows I'm going to be doing a rotation of these workouts, basically. It gives you a brief prompt about that. Then anything that you say to it that is even remotely interesting, it will remember it for you.
But I guess my question is, how does it remember that? If I were naively just thinking about how I was able to do this, I might extract some structured things that I wanted to remember and store those in a database somewhere.
Yes.
Are you doing that, or
Yes.
just from your answer, yeah, it wasn't clear?
Yes, we are.
Yeah.
We are storing it. Yeah, if I tell it like, hey, by the way, I broke my arm today. You can see here, it's setting memory, set user profile details. I don't know if you're able to see that.
So there's a tool called basically extracting
Yes.
structured thing that you're tracking.
Right. So the hard part there is the router needs to be smart enough to be like, oh, that sounds like something I should remember.
Right.
But it's really bad at doing that. So what you want to do is you want it to like over select that choice, and then it can get changed to another model that's like, hey, I think we should store this, but given all of this other context, do you think I should? And then you provide a tool called do nothing. We have tools called do nothing all over the place, and we give it that out because otherwise it will choose to do something. So we'll say do nothing, and at the end it'll actually store that. So in this case, it decided, yeah, this was important, so it called that, and then changed here, and it decided after doing that, this was the prompt that it received. User broke their arm today. And then after it received that, it decided, okay, I'm going to actually set a memory, and then I'm going to follow up on their broken arm at some point in the future. So
what did it say about the broken arm? Did you say sorry? Cancel your.
No, it'll give you workouts. It'll give you workouts. It's pretty crazy.
Does it know how long it takes to recover from a broken arm and start getting back on
I mean,
track?
it's guessing. It said 6/13, so in 1 month it's going to check in and say,
That's pretty impressive.
yeah.
So where is it getting that information? I've used several semi-AI-enabled workout apps, and I've never been fully happy with them. So if you're looking for more beta testers, that'd be great. But anyway, I'm just curious. I mean, how does it know? How does it know how many reps you're supposed to do? How much weight you're supposed to be lifting? How many
Right.
sets you're supposed to do? I guess that information's out there on the internet. I'm just curious.
Yes, that's one of the reasons we use a really high-end model on the initial exercise creation. And those models have a lot. They have a lot. And we'll use reasoning models on all of them. And they'll reason about, they'll think about it and do lots of iterations. And then in the onboarding, we ask everything that we can about you. So we'll ask your height, your weight. Often the onboarding is sort of like allowed to take you where you go, right? But on most of them, it'll be like, oh, okay, you work out already? Great. What's your 1 rep max on the bench press? Oh, you're a runner? How many miles did you run this week? Right? And so it'll try to understand what you need, and then it'll use that to start building it out, And sometimes it gets it wrong. So I don't know why the chat interface is working, but like when you're actually in the app, you get a chat interface, so you can chat with the trainer like in the gym. It'll have all your exercise and workouts there. And if it's like wrong on your first 1 or 2, you can just say like, hey, you put my bench press at 125 pounds. I usually do 250. Can you just fix the rest of my exercise based on what you think I'd like? And it'll just redo your whole thing.
Cool.
And then once it has a few of those, like once you've done a few workouts, now it knows you. And so that's part of the RAG that we pass in every single time, and it knows how to do the job.
So if I can offer you guys feedback.
Okay.
Yeah, I bet if you'd said you had a joint pain, it would really mess with you. Really hard time.
Dude, it's surprisingly good. I have a sister who's a quadriplegic, and it makes exercises for her. Full quadriplegic, barely move her hand. It'll do like neck exercises and like little stretches. It'll even be like, do you have somebody who can help you do these? Stand up and sit down, things like that. It's pretty crazy.
We just wrote a prototype of an agent form that does adversarial prompting, so if you really want to test it.
Yeah, we have a little bit of that. We do run an eval. We have this eval that we run. Try to show you this. I mean, I'm done, so you guys feel free to just.
Yeah, while you're looking at that, if you're able to talk about the platforming of the rest of the infrastructure, I'd be curious kind of where you guys went with, you know, what you're using to keep state and things like that on your side. Is it, you know, sort of traditional Postgres-y kind of stuff, or?
This is,
you're generating a lot of state to begin with, and there's a lot of data that you're gonna wanna be able to reuse training data, really, like where you're keeping that kind of stuff. I'd be curious, like what strategy you use for this thing.
it
If
is
you're
fully Cloudflare.
It's all cloud.
All Cloudflare. We use all of Cloudflare's kind of like crazy edge stuff. So
Because it was quick and easy?
no, there's some of that, but we want to be able to scale the LLM requests in parallel really easily.
Okay.
And so having a node server do that for us is just a real pain. And Python, in my opinion, is just like not a great option for actual production hosting. There's not, like, Cloudflare's actually getting better at it themselves, but there's not that many good options for super parallel.
So when you say Cloudflare, do you mean CloudFront, or you mean Cloudflare?
Cloudflare has a product called Cloudflare Workers.
Yep.
So we use Cloudflare Workers, we use their D1 distributed database, we use R1, which is their like S3
I didn't
thing.
realize they get that part of the infrastructure as a service.
Yeah.
R2.
Yeah, a bunch of different stuff.
I
R2,
just-
that's right, R2.
I just caught a podcast on it, like, it's Software Engineering Daily, I think. Just had a podcast on it like 2 days ago.
We use their thing called durable objects, which is this really strange compute primitive. It's like a tiny compute primitive that has data, like a SQL-like data storage option attached to it, as well as WebSocket connections, as well as HTTP connections. But it's like an instance that lives. Like you can have infinite instances of this. So each conversation thread is an instance of one of these D1
When you say that,
objects.
it's not like it doesn't just die at 15 minutes kind of stuff. So it's
No.
long running.
Yeah,
So are they just little containers that they built, or?
sort
I
of.
mean, you probably won't know.
Yeah, it's abstracted from me for the most part, but yeah, sort of. It's a weird API. It's not particularly developer friendly to use. I don't know that I would recommend it.
Yeah, Cloudflare traditionally hasn't been real good at that kind of stuff.
No,
Interesting.
they're really going into it hard though now. And the nice thing is, like, I know this thing will scale. That's like the one thing I'm not worried about at all. So. This is like how we run evals. That was like an onboarding eval. So we ran 3 of the same personas, five different personas, 3 different times. We take their average score. We like score the lowest response of any of them, and then this is inversely related. The final score is inversely related to how bad the score was. So like if one of these gets a 1 somewhere in there, that like for somebody's onboarding journey, a 1 message coming in could be like catastrophic. Like they're never going to use the product. So we want to very heavily weight those out of the system. So this is sort of how we've been making recent decisions on, did we do something good when we added something to the prompt, or did we do something bad? And then I can store these and then save basically a cold storage copy of it, run the test again, do a comparison between them and see if I, on average, went.
So you're just using SQL stuff. You guys didn't build like a file-based, YAML-based, file-based retrieval system, anything crazy. Just using SQL, an object store and logs where you need them, and pretty basic.
That's right. Yep. Yeah.
We use scoring. So, you noted the scores. I'm kind of curious about like what you're scoring specifically.
So the way that this works is this same onboarding flow that we saw over here. Where that was. Up here.
Oh, there's loads of
There are, yes. They're not great, but they exist. So this is all, Cloudflare has a open source project called MiniFlare, which emulates their entire Cloudflare infrastructure. So you can effectively run it local. So this is running exactly what we run in production. So here you can see, so this is basically a completely brand new, cleaned out thing. These are all the conversations that just got generated. So you can see there's 3 of each of the names. And then to answer your question, what it's scoring is it's taking each reply. This was obviously generated by the AI in the eval. It's taking each reply to the user and determining on a scale of 1 to 10, basically how good was that reply? Like, was that directionally what we wanted to be talking about? Would the user be pissed off by it? Right? There's like some system prompting around that. Give me a score 1 to 10, and then it just goes through and checks them. And this is what I was saying. If you try to use a cheap model to do this eval, it does terrible. So you have to use a relatively expensive model to say whether or not they were good or bad.
So I guess like, do you have like a reference that you use to measure the AI's output against, kind of like, because like right now it's going to be subjective to the AI prompt, right? Like,
Yes.
okay.
Yeah, it's purely, it is not objective.
It's all relative, internally relative.
It's all internally relative, yeah. There is no like objective basis. It's because like each time it's going to be completely different. So it's only relative to itself and its own scoring mechanism.
Do you anticipate your customer success team supervising that process to evaluate whether truly satisfied, happy customers are scoring well?
Well, we're so early on
Yeah,
that we're just getting manual feedback. Although we do run this in a shadow eval mode, so it is evaluating the conversation, and then we are able to say like, "Oh, that was a bad message." And in general, it's pretty accurate. Like a low score definitely is a bad message. The only question is sometimes a questionable message will slip through and be considered good. So, yeah. Any other questions?
All right, this was a ton. Thank you.
Yeah, good presentation, thank you.
I want to really thank and appreciate your time.
Thank you.
Just sort of moving on in the agenda, I will also remind myself of our sponsor, X Studio. And they do have, I noticed, some day passes. There's a little like business card type thing. So that's on near the name tags over there if anybody wants to grab one of those and